Hey everyone, welcome back. I'm Darshan, and today we're diving into something that's been absolutely fascinating me for the past few months, building agentic AI systems in Rust. Now, if you've been following my content, you know I love building high-performance systems. But agentic AI? This is where it gets interesting. We're talking about autonomous systems that can plan multi-step actions, use tools, make decisions, and work toward goals without constantly asking humans for permission. In the next 30 minutes, you'll understand what agentic AI actually is and why it's different from ChatGPT, why Rust is becoming the go-to language for production AI systems, real-world examples you can actually build, the exact roadmap to get started today, whether you're a Rust developer curious about AI or tired of Python's limitations in production. This video is for you. So stick around. Let's build something amazing. Before we jump in, hit that subscribe button and turn on notifications. New content on AI, Rust, and systems programming drops daily. And if you're building cool projects, drop a comment. I read every single one. Let's go. Okay, first things first. Let's clear up what agentic AI actually means, because this term gets thrown around everywhere these days. You know traditional AI, right? You ask ChatGPT, what's the weather in Surat? It answers, done. That's reactive AI. But agentic AI, that's autonomous. These systems can think several steps ahead, use tools, make decisions, and complete complex workflows without you telling them what to do at every step. Let me give you two examples. Traditional AI, you ask, what's the weather tomorrow? ChatGPT, it's sunny and 28-day C, done. Agentic AI, you say, plan my weekend trip to Mount Abu. I want to leave Saturday morning and return Sunday evening. Find me good hotels, check the weather, calculate driving time, and give me a complete itinerary. Now the AI system needs to search for weather forecasts, query hotel booking APIs, calculate driving routes, coordinate all this information, present you with a complete plan, all without you micromanaging every step. That's agentic AI. Real-world examples are everywhere now. Customer support, one agent handles fake queues, another processes refunds, a third escalates complex issues to humans. No manual routing. DevOps assistance, an agent monitors your systems, detects issues, diagnoses problems, and sometimes even applies fixes. Your infrastructure manages itself. Research agents, autonomous systems that gather data from multiple sources, analyze trends, synthesize information, and generate reports. Think automated market research or competitive analysis. Coding assistants, agents that understand your entire code base, create GitHub issues, suggest implementations, manage project boards. They're like senior developers that never sleep. Finance systems, stock analysis, lead scoring, even trading, all autonomous. The pattern is clear. Any workflow that requires multiple steps, tool usage, and decision-making is becoming agentic. By the way, have you built anything with AI agents? Drop a comment below. I'd love to see what you're working on. Now, here's the honest truth. Python dominates AI development right now. NumPy, PyTorch, TensorFlow, the ecosystem is incredible. For experimentation and prototyping, Python is unbeatable. But when you move from cool demo to production system that runs 24/7 and handles real workloads, Python starts showing its cracks. Let me explain. Problem 1. The global interpreter locked the GIL. In Python, only one thread can execute bytecode at a time, even on multi-core systems. This is a fundamental limitation. Imagine you're building an agent system where multiple agents need to call LLM APIs, which blocks waiting for responses, query databases in parallel process, results concurrently, handle requests from multiple users in Python with the GIL. This becomes a bottleneck nightmare. Only one agent can make progress at a time. Your system becomes I/O bound instead of truly parallel. Rust, no GIL, true async, await, multiple agents run in actual parallel, not fake threading. Problem 2. Type safety in Python. Your agent might fail halfway through a critical task because of a type error that only shows up at runtime. Imagine an autonomous system withdrawing money from an account, modifying a database posting on someone's social media, managing infrastructure, one type error. And you've got a financial disaster or security breach. Rust compiler won't let you write that code. Types are checked at compile time. Your agent either passes compilation and works reliably, or you catch the bug before deployment. This is a game changer for production systems. Problem 3. Memory management. AI agents often run 24/7. They're long-lived processes. In Python, even tiny memory leaks compound over days and weeks. You end up with zombie processes consuming gigabytes of RAM. Rust has no garbage collection. Memory is managed through the ownership system. Your agent runs forever without mysterious slowdowns or memory bloat. For critical systems, this reliability matters. Problem 4. Raw performance. Python's great for development speed, not runtime speed. When you have thousands of agents or need sub-millisecond latency, Python becomes a bottleneck. Rust gives you CPU+ level performance with safety built in. Your agent system handles 10x more load without additional hardware. Look, I'm not saying Python is bad. Python is perfect for research and prototyping, but for production, for systems managing real infrastructure and making autonomous decisions, Rust is the better choice, and honestly, that's why I'm diving into Rust AI agents. I want to build systems that don't wake me up at 3 a.m. with mysterious crashes. Here's what excited me when I started researching this. Rust is already the backbone of AI infrastructure. You just don't see it directly. Major AI platforms, we're talking about organizations managing billions of requests, are building their core infrastructure in Rust. They expose Python APIs on top, so you feel like you're using Python, but underneath? Rust. It's the hybrid approach. Python's ease for development, Rust's reliability for production. The ecosystem has matured significantly. In 2004 and into 2025, several frameworks emerged specifically for building agentic AI systems in Rust: autoagents, llma, Rust Crate that provides reasoning engines, tool use capabilities, and multi-agent collaboration. This is production-ready code. Rig framework, high-level abstractions for building agent pipelines. You define agents, their capabilities, and how they interact. The framework handles the complexity. Composio integration, Rust bindings for integrating with external APIs and services. Connect to GitHub, Linear, Slack, databases, search engines, all from your Rust agent. Liquidos, a case study showing how to build sophisticated multi-agent systems in Rust. We're past the interesting experiment phase. This is real, production-ready infrastructure. There's also a bigger trend. Rust is becoming the language for data science and AI workloads, especially for stable, efficient, long-running computations. Projects like Polars are replacing Pandas for data processing, ORT for ML inference, GRs for tensor operations. The ecosystem is maturing fast. Companies are choosing Rust not because it's trendy but because it solves real production problems: reliability, performance, concurrency. The timing is perfect. The ecosystem is mature enough to build real things, but early enough that you can still contribute meaningfully. If you want to be ahead of the curve, now is the time to explore Rust for AI. Let me show you the architectural advantages that make Rust special for AI agents. Advantage 1. Type safety prevents disasters. When you're building agents that autonomously manage infrastructure, you want guarantees. Rust catches entire classes of bugs at compile time. Your code either compiles and works reliably, or you fix it before deployment. Advantage 2. Memory safety. Without garbage collection, AI agents are long-lived. In Python, garbage collection pauses are unpredictable. You might freeze 400 ms while GC runs. In a high-frequency trading agent? That's money. Rust has zero runtime overhead, no garbage collection, no mysterious pauses. Perfect for production systems that need predictable latency. Advantage 3. True concurrency with async await. When Agent A waits for an LLM API response, instead of blocking, your runtime can process requests from Agent B and Agent C. Rust async runtime, Tokyo, gives you this for free. Thousands of concurrent operations on a single machine. Python can simulate this, but it's fighting the GIL. Advantage 4. cost abstractions. You can write high-level, expressive agent code without sacrificing performance. Define your agent logic clearly. Let the compiler optimize it away. And you get readable code with C2+ level performance. C2+, that's rare. Here's the architectural pattern that emerges. Agent struct encapsulates the LLM model, system prompt, capabilities, and an HTTP client. This is your agent's brain. Type tools. Each tool, GitHub API, database, search, is a strongly typed struct with clear interfaces. No stringly typed chaos. Trait-based coordination. Multiple agents coordinate through traits. You might have a router agent that delegates to specialized agents, or a pipeline where output feeds the next input. Async runtime. Tokyo handles all the concurrency. Multiple agents work in parallel without blocking. The result? Clean, type-safe, concurrent agent systems that scale. This is the kind of architecture you build once and it runs for years without surprises. That's why I'm obsessed with it. Let me walk through 3 real examples that inspired me. These aren't toys, they're production-ready patterns. Example 1, database query agent. Imagine you ask in plain English, show me top customers by revenue last quarter. The agent parses your request. Which database? Which table? Which metrics? Generates valid SQL, executes the query. Returns formatted results, all autonomous. No SQL expertise required. This is built in Rust with async database connections. Multiple users can query simultaneously without blocking. Example 2. Multi-agent coding assistant. This one's sophisticated. You have a supervisor agent that understands your request in natural language, a code agent that reads your repository, understands the architecture, a GitHub agent that creates issues, manages pull requests, a linear agent that updates your project tracking. You say, add a new feature for user authentication. The system creates a GitHub issue with detailed requirements, creates a linear ticket linked to the issue, generates starter code in the right location, adds tests, creates a pull request, all orchestrated automatically. It's like having a senior developer that never sleeps. Example 3, AI-powered research agent. This agent takes a research topic, uses search APIs to gather information, reads and summarizes articles, identifies trends and patterns, generates a comprehensive report built in Rust with async web crawling. You get parallel searches, efficient memory usage, and a reliable system that doesn't leak memory after processing thousands of sources. These examples are happening right now, not in labs, in production. Companies are shipping these, and the pattern is consistent. They all need Rust's reliability, concurrency, and performance. Okay, you're convinced. You want to build AI agents in Rust. Here's the exact roadmap. Phase 1. Start small. Pick a focused use case, a research assistant, a database query agent. Something you can complete in 2-3 weeks. Don't try to build AGI as your first project. Phase 2. Learn the pattern, study existing Rust agent implementations. Understand core abstractions. And see how async workflows work. The Composio tutorial and rig framework documentation are excellent starting points. Phase 3. Build the foundation. Create a basic agent struct that can communicate with an LLM API, OpenAI, Claude, Gemini. Handle responses. Manage state. This takes a weekend. Phase 4. Add one tool. Integrate a single external API. Maybe a search tool, maybe GitHub, maybe a database. This teaches you tool calling patterns. Phase 5. Iterate. Once basics work, add more tools, implement memory, add planning logic, explore multi-agent coordination. You grow your system incrementally. And here's my advice. Build in public. Document what you learn, share code, contribute to open source projects. The Rust AI community is incredible. Everyone's learning together. Your insights help others, and you'll learn faster. I'll be documenting my journey on Medium and GitHub. Follow along. Let's figure this out together. We're at an inflection point right now. AI is moving from research to production, from demos to systems managing critical infrastructure. As that happens, the demand for reliable, performant, safe agent frameworks grows. Python will always be great for research. But for production, Rust is becoming the obvious choice. Getting in now means you're growing with the ecosystem. In 2027, Rust AI agents will be the standard. You want to be ahead of that curve. I haven't built my first AI agent yet, but I'm starting this journey now. And honestly, I'm excited. The combination of Rust's performance and safety with Agentic AI feels like the perfect match. It's like two powerful tools finally meeting. If you're a Rust developer curious about AI, or if you're frustrated with Python's limitations, this space is worth exploring. Seriously, I'll be documenting everything on my Medium blog and GitHub. Follow along if you want to learn together. Before you go, please subscribe to the channel. New content on Rust, AI, and systems programming drops every single day. You don't want to miss this. Join our Discord community, link in the description. That's where we discuss technical problems, share projects, and learn together. The community is amazing. Support the work. If this content helps you, consider buying me a coffee through Buy Me a Coffee. That link is in the description too. Every coffee funds more content like this. Drop a comment. What excites you most about AI agents? What would you build? I read every comment and respond to many. Check GitHub. All the code, resources, and examples live on my GitHub, Aram DevHub. Aram, start the repo if this resonates with you. Thanks so much for watching. I'm Darshan. Next video, we're building our first AI agent from scratch in Rust. It's going to be amazing. See you there. Now go learn some Rust. Peace.